equal to say a function, and then I would say well, it didn't tell me what's return, so I'm gonna say x return. This should be return now. Oh, I cannot do that right here. I have to apply it. Then check the return. Okay, so we have the example of L is the 1 minus 1, 3.2, then apply L, print L. This should just return 1, 2. Notice this actually changed the L outside of the function. This is because apparently the L here is passing as a reference. So the best way to see this is through the Python tutorial. Then you will see which one is actually changing there. So let me copy paste out the code. So we first define the function. And then put the list and then run the code. Okay, so visualize the execution. Define the function, apply to each with the L as the list input, F as the function. And then now we have that list, 1 minus 2, 3.1. Now, here's the interesting part. So we are going to call that function. Okay, so now you see the L is linked to inside of that function L. Notice that L is inside of now is in this gray space, which is inside of the function, but that L also point to the same object. So now we are going to go over the loop. Okay, so I equal 0. Oh, I is on the 1. Okay, so 1 it doesn't, you don't, because 1 plus absolute is not changed, but 2 you now see it's changed. It was minus 2. See here, it was minus 2. Yeah. In the beginning, but now it is now plus 2. So what we are changing is actually not the inside of the function. It's actually this object in the global space. So, yeah. Well, 3.4, that one you don't see any change though. Yeah, and here now it's clear. It return, even though it return nothing, none, but the actual list was changed because this passing as a reference, because they point to the global object. So this is probably also a very good revisit about the scope of the function and how the list object are referenced, are passing as a parameter. So, okay. Okay, so I don't have to go over this one here, although you could check the return, that should be the same. I think, is that the same thing? Hold on. Minus 2. Oh, somehow there's a typo here. We're changing this to an integer, not this one. So, okay, so now the next example, we are not only passing a function, we can also passing a list of function as object. if a function can be used as object, we can use that object as the element in a list. So in this case, L is now a list of a function with now each element inside L is actually a function. So now this I guess a bit awkward to call this apply functions as a function. So in this case, we have the function was what ABS and integer. Okay, apparently Colab still think that int is the integer type keyword. It looks like the Colab cannot tell ABS and integer actually is a function as a typecasting. That's why they show up in different color. It's okay. I mean, it's apparently that's a problem. That's an issue in Colab. So, but we can't just ignore that for now. So if we apply the ABS on the minus 9.5, so this is 9.5. If I apply integer on 9.5, that's just take the floor of that. So this is passing a function as the object in the list. So, and Python actually has another shorthand or a useful way, something called map. I don't recall Java have this, at least in the base package. Someone may write a Python, a Java package to have something like a map, but in Python, this is actually in the base package. So map will be almost like if you have used some other language or in R, there's an apply function. In another language, I forgot what it is, there's a lambda function. Actually, Python also has lambda function. It's very similar to that general way of applying function. But this is how map works. So apply the integer as a function to a list. And this will be this apply that and then print it out. So the return of the map is also an iterable object. So okay, so here we apply integer, which take the floor of the floating input. So integer of 1.1 is 1, integer of minus 2.5 is minus 2. So 3.2 is 3. They basically remove the decimal part. Minus 4.9 is minus 4. So if I change,
it basically just changes the type for a list. So is that what it's doing?
No, it is a map object. So in fact, a good question. In fact, here at the bottom, that's a good question. In fact, that's what my next cell trying to explain. It is actually not a list, it's a map. This is actually very common in Python, so very often, I don't know exactly the philosophy behind this, but my understanding this will improve the running efficiency. So instead of converting that into list, it actually is the map object. And the difference between the map object and list will be right here. So if it's a list, you can say x1, but if it's a map, you actually cannot, because it's iterable, but not so-called indexable or subscribable. So only if you do typecasting. So if you do a explicit typecasting, and then you can put it back. So and then it's okay. But that apparently is more expensive. This is, I guess you can just interpret that that's an idiosyncratic feature of Python. I don't know the philosophical reason why many of the Python functions are defined this way, but my own guess will be probably have something to do with the efficiency of those objects. Otherwise, you have to constantly do a typecasting. So it's actually not. Basically, the question is map changing into a list? The answer is no. So yeah, it actually is a map object. So I guess I don't see who answered that question. That's a good question, and the answer is actually a negative. So there are some other Python similar function. It also behave in similar ways. I actually don't know exactly the philosophy behind that design. So this is also basically a software or language design issue. When those people design the Python language, it decided the map function doesn't return a list. It's just a map object itself. So somehow that's decided that way. So, of course, if you do a typecasting list types, and then it is